Alright, so here's your notes, the final notes on magnetism. Just real quick, at the top right or top corner, go ahead and hit week 3 notes. Make sure you write that down, and then make sure we're going to title this Magnetic Fields. Alright. So there's only a couple things we need to take down for this. First, and the most important, magnets always have 2 poles. They have a north and a south. So right here, I'm going to draw a little magnet. It's called a little bar magnet. And I'm going to put a line down the middle because half of this magnet is considered the North Pole and the other half is considered the South. Now generally, when we draw these out, the north side of the magnet in diagrams like this, you'll always see it colored red. Sorry, I had to get my red. The north side of the magnet is usually colored red, and the south side is usually black or gray or whatever other color the magnet material tends to be. But sometimes you'll see them actually painted black. So there, now we know we have the north and south poles. No matter what, you're always going to have a north and a south pole. If you have a magnet, and it's got a north and a south pole, and you break that magnet in half, both of those halves will gain a north and south pole. There is no such thing as a magnetic monopole or only one pole. There's got to be 2, no matter what. Next is when we draw magnetic field lines. Magnetic field lines are always closed. So back when we were drawing gravity and electricity field lines, they would always start in the center and they'd come out, or they'd start out and they'd come in. Magnetic field lines are a little different. They will always come out from the north and in to the south. So once again, if this is my north pole and this is my south pole, the magnetic field lines for magnets will come out at the north and they go in the south. So I have my lines of force pointing in that direction. And once again, I will make sure that my north pole is red. And the south pole down here is black. Now remember, if you need to pause this video at any time to make sure that you have what I have, you may do that. Let's just put a note over here. Arrows point from north to south. Arrows point from north to south. All right, next. Magnetic fields are caused by the way some substances are naturally structured. Magnetic fields are caused by the way some substances are naturally structured. One of those substances is iron. Iron can very easily form a magnet. Now this has to do with the individual charges within the atoms and molecules of structures. We don't have a whole lot of time to get into it, but since we did talk about that mass creates a gravity field, charge creates an electric field, the structure of some substances, mostly metals, and definitely lots of different types of iron, tend to be magnetic. They are what creates a magnetic field. Now, in the next unit, we'll also see how a changing electric field can generate a changing magnetic field. But we're going to wait for that till after this test, so don't worry about that too much. The last thing that I think is super important about magnets that I want you to know is that Earth has a magnetic field. And Earth's magnetic field protects us from harmful solar rays. Now, you may be thinking, but Reyes, plants need the sun. Those solar rays are good, right? Well, yes and no. The sun emits a lot of light, and not all of it the useful kind that plants use to survive. Some of the light that the sun emits is basically too powerful. And if that light gets to the surface of Earth, it can actually penetrate living objects and cause damage to their DNA. Now, sorry, side note here, you'll notice that I drew the in at the top, and you might be, well, wait, that's not the North Pole. Well, it is the North Magnetic Pole. Turns out that our magnetic poles are reversed. So our magnetic north is actually at the South Pole, and our magnetic south is actually up with Santa Claus. So this is our magnetic field. It's like these looping lines that go all the way around Earth. And when the sun emits its harmful radiation, it gets pushed away and goes around Earth. Now, not all of it does. Some of it gets trapped, where you see these field lines actually go into the top and bottom of our planet. And as I think some people have pointed out in class before, this is how you get those aurora borealis in the north and the corona borealis in the south, these northern and southern lights that light up the sky with these big, beautiful greens and blues. And that is from these charged particles coming off the sun interacting with other charged elements within our atmosphere. All right, so here's everything you need. A picture of this will be next so that you can see it. in all of its full glory. Make sure you get this down in your notebook. This will help you out on the information to come and also on the test tomorrow.